Welcome to 2.2 practice problems, funding the future. Okay, select all polynomial expressions that are equivalent. Okay, so we come down, we look at what's equivalent. And C has the same terms and E has the same terms. It does matter to order. The problem up here, the example is in proper order where the highest degree is first, and then you go in descending order down to a constant term which has no exponent, no variable. So C and E are like, all the terms are the same, the negative 7x squared, and the other ones, the negative change places. And with A, you cannot add different letters and numbers together. You can't do it. Okay, let's take a look at problem 2. This is just like Claire's aunt. So what you have to do is pull out the important numbers. 500 is at the end of the first year, 200 at the start of the next year, and 600 following the years. Now, let's write an expression for the value of the count at the end of 3 years. So after 3 years, what we have is 500 got the X in the first year, so it had 3 years to grow. 200 had 2 years to grow. And 600 had 1 year to grow. Okay, now if you put this into the calculator, what does it amount to the nearest cent of the count at the end of 3 years if the interest rate is 2%? We're going to come back to this in Unit 4. But if you're really interested, basically what you do is put 1.02 in for X. X is 1.02, and you should get a dollar amount of $1350.68. Okay, let's look at number 3, evaluate. We see the word evaluate. That tells us we had to get this down to a single number. So what I'm going to do is take 5, put negative 2 in, square it, minus 3 times negative 2. Make sure you use parentheses. If you put this in the calculator just like it is written, you should get negative 1. If you're not getting negative 1, check how you put it in the calculator or calculate it by hand. Negative 2 cubed is negative 8. Negative 2 squared is positive 4. And negative 2 to the first power is just negative 2. So 5 times negative 8 plus 8 times 4 plus 6 plus 1. 8 times 4 is 32. Plus 6 is 38. Plus 1 is 39. 5 times 8 is negative 40. So that gives us negative 40 plus 39, which gives us negative 1. Okay, here we have another open top box problem. But what is this question asking us? Okay, so if we read through it carefully, what are the dimensions of the rectangular piece of paper? So we know we cut 2x off of each side. So that means that the dimensions of the piece of paper must be this number and this number. So our original piece of paper was 7 by 5. Okay, again, a rectangular playground space. Draw your little rectangular playground space. First thing you want to do is draw your space and then draw your fencing. We have an X here and an X here for our side lengths. This is our building. Daycare building. So this is our daycare, whatever you want to call it, ABC Learning or something. This is 200 minus 2x because we need the sides. And what is the expression? So I'm going to start with B first because it doesn't make sense to go to A until you go to B. So our expression for the area is 200 minus 2x is one side and x is our other side. Now, when we stick in 200 minus 2 times 50, double parenthesis it, times 50. Put it in the calculator just like it's written now. You should get 100 times 50. You should get 5,000. meters squared. Meters squared. Okay. What is a reasonable domain? So x has to be bigger than 0, and it has to be smaller than the side. So 200 minus 2x is equal to 0. If we set everything equal to 0, we get the maximum space. And x is equal to 100, which means this must be less than 100. Tyler finds an expression that gives volume of an open top box in cubic inches, blah, blah, blah. Okay, so again, just like in the previous practice problem set, we cannot have negative volume. So our domain has to start at 0 and go to 3.5. So 0 should be less than x, should be less than 3.5. Approximate volume, draw a dot at the top, go back. Guess a number there, 52, 53, whatever number you think is close. You can go anywhere from 52, maybe to 54. I think 55 would be a little much, but maybe I didn't draw my line straight. If you went to 55 or 51, I wouldn't be mad at that, but somewhere in the mid 50s. Okay, let's look at the last problem. All right. We have two terms. Now, what do we do with them? We look in between them. There's no sign in between them. So when two things are next to each other, that means multiply. So what I like to tell you guys to do is draw the distribution arrows. When we see one thing outside of a group, that means distribute. So the 3 has to go here. The 3 has to go there. The x has to go here and there. Now, some of you guys like the box method, where you put things on a box. Whichever you guys like is fine with me. Does not matter to me, as long as you multiply. 3 times 7 makes 21. 3 times negative x makes negative 3x. You can multiply a letter to a number. They just get mushed together. Plus 7x minus plus x times negative x is negative x squared. When you multiply variables, the exponents change. When you add and subtract variables, the coefficients change if they're the same term. So these two are the same. You get 21 plus 4x minus x squared. And let's do it on the box. We get 21, 7x minus 3x minus x squared. You get the same thing, 21 plus 4x minus x squared. It's not written properly, but we'll worry about that later. Are these the same as the other ones? It's not the same as this. It's not the same as this. Negative x and positive x squared. Negative x squared and positive x squared are not the same thing. If there's no sign in front of a term, it is positive. People forget that a lot. So if I was to write this properly, it should, negative x squared should go first. That's how it should be written, but we're going to talk about this in the next lesson.